When audio is captured digitally, it's recorded in two dimensions. There's an up and down, which is the bit depth, and then there's left to right, which is sample frequency. And I'm going to talk to you about bit depth now, because the bit depth is what determines the dynamic range of the digital audio. So let's look at the three most common bit depths for digital audio. There's 16-bit, 24-bit, and 32-bit. Now, the bit depth determines the dynamic range of the digital audio. Now, the higher the bit depth, the wider the dynamic range. Not the louder, it's wider. The dynamic range doesn't get louder with higher bit depths, it gets wider, with more variation between the softs and the louds. Now, in digital audio, every time you add 1 bit to the bit depth or the word length, you double the dynamic range. So let's take a look at a visual representation of bit depth, and we're going to use this single cycle of a waveform, which is a sine waveform, to illustrate how bit depth relates to amplitude. So the single cycle is represented by a peak on the left and a valley on the right to complete one cycle. And I'm going to quickly fill in the blank there with yellow so that you can see this entire single cycle. Now, the height of the peak or valley is what determines the volume or the loudness of digital audio. So there's a measurement between the quietest, which is located at the center of the waveform here. That's known as infinity. Infinity is absolutely as quiet as digital audio can possibly get. And then a measurement is taken of that waveform from the peak and from the valley. In other words, the center to top and the center to bottom. And the measurement from the center of the waveform to the extreme is known as the dynamic range. And all bit depths have a maximum value of 0 dB. So different bit depths won't give you a larger dynamic range. They all bottom out at 0 dB, or the extremes of that amplitude measurement. So the positive part of the waveform has a peak expression of 0 dB, and the negative part of the waveform also has a maximum value of 0 dB. And that's why volume should never exceed 0 dB, because when you do, you clip or distort the audio signal. So never ever clip anything, because when you do, you send those positive and negative parts of the waveform over 0 dB, and they sound bad because they distort. Now let me show you how bit depth and dynamic range is expressed inside of Cubase by going back to that perceived loudness project that we were listening to earlier. I'm going to take this snare drum track and I'm going to double click it to reveal the sample editor window. Then I'm going to make sure that the definition tab is selected and that my scale over here is set to dB instead of percentage. So set that to decibels or dB. And then I'm going to take this snare drum hit and I'm going to click and drag down on that display until I see about one cycle of the waveform. I'll just wait until it fills in with yellow so it looks somewhat similar to the waveform that we've been looking at. And you can see that it has a single cycle starting here and going through here, and it has a maximum positive part of the waveform and a maximum negative part of the waveform. The center of that waveform is expressed as infinity, or as quiet as digital audio can ever get. Then on the positive side of the waveform, it goes all the way up to 0 dB. Then the negative part of the waveform also goes down to 0 dB. So there's an expression of volume that starts at the center of the waveform, and then there's a measurement for the positive side and one for the negative side, both of which max out at 0 dB. So now let's look at how those bits relate to that single cycle sine wave again. First, bits 1 through 8 are located at the negative portion of the waveform, and bits 9 through 16 are analyzing the amplitude of the positive part of the waveform. So what does a 16-bit depth afford us as far as a dynamic range? There's a couple of different ways to look at it. You can look at it as degrees of resolution, or of amplitude resolution. So a 16-bit depth provides 65,536 degrees of amplitude resolution, or a dynamic range of 96 dB. Now, audio CDs have always been 16-bit, but remember that every time you add 1 bit to the bit depth, you double the dynamic range. Now, let's see how that works. If a 16-bit depth gets you 65,000 degrees of resolution, if you were able to add 1 bit to that word length, like a 17-bit recorder, which has never existed, you would double its amplitude resolution to over 131,000 degrees of amplitude resolution. So when you compare 16-bit to 24-bit, since it doubles every bit, it's an exponential expression. So a 24-bit audio recording has 16.7 million degrees of amplitude resolution. And when you get to 32 bits, you get 4.2 billion degrees of amplitude resolution. Now, how does all of that equate to dynamic range? Let's take a look in decibels. A 16-bit resolution gives you 96 dB of dynamic range. A 24-bit system gives you 144 dB of dynamic range, and 32-bit gives you a mind-boggling 1,536 dB dynamic range. But bear in mind that audio equipment and the theoretical limits of what copper can give us really limit audio equipment to a dynamic range of about 120 dB. So you might think that recording your Cubase project at 24-bit would be plenty because you still have more than 20 dB of dynamic range higher in a 24-bit system than audio equipment is capable of reproducing. But I'm going to recommend that you record all of your Cubase projects in 32-bit float, or also known as 32-bit floating point bit depths. And that's because 32-bit float is the native bit depth of the Cubase audio engine. And the primary advantage of that is once the audio has been recorded into Cubase, 32-bit floating point makes it impossible to ever clip that audio level. And that's really important because it gets really easy to push a lot of level throughout Cubase. Now let me show you how you can set the bit depth in your Cubase project, and bear in mind that you have to set the bit depth before you start recording any audio inside of Cubase, because setting the bit depth has no effect on previously recorded audio tracks. So if you did a bunch of recording in 16-bit or 24-bit in the project, there's really no advantage in converting them to 32-bit. So you really need to do this before you start any recording in your Cubase project. But it's done by going to the Project pull-down menu and selecting Project Setup. And then in the Project Setup window, you're going to come down and find the bit resolution. And you can see that you can choose 16-bit or 24-bit, or I'm going to recommend that you do all of your recording in 32-bit. Yes, it's going to take a little bit more hard drive space to record in higher bit depths, but the advantages of 32-bit float are well worth it. Now you'll notice that you can also set the sample rate, but I'm going to talk about sample rate in the next tutorial.